Now we shall solve a first order differential equation dx plus y dy equals x squared y dy. By examining this equation, we can see that this can be solved by using separable differential equation method. And the first step in solving using separable differential method is by reducing the given equation into its standard differential form. First is that by examining the equation, we can transpose the term y dy to the right side of the equation, forming dx equals x squared y dy minus y dy. And by factoring out y dy in these both terms, we will get dx equals x squared minus y quantity times y dy. Then we will divide both sides by the term x squared minus 1, resulting dx over x squared minus 1 equals y dy. The second step is by integrating the obtained standard differential form equation that we get by separating the variables of the equation. Here, integrating dx over x squared minus 1, one way of integrating it is by using integration by partial fraction. And by using integration of partial fraction, the integration of dx over x squared minus 1 will result to the natural logarithm of x minus 1 all over 2 minus the natural logarithm of x plus 1 all over 2. And simply the integration of y dy is just y squared over 2 plus the constant c. Simplifying further the equation, we'll just multiply both sides by 2, obtaining the natural logarithm of x minus 1 minus the natural logarithm of x plus 1 equals y squared plus c. Here, using the identity of the natural logarithm, we can simplify the left side of the equation, obtaining the natural logarithm of x minus 1 over x plus 1. Here, in order to simplify further the equation, we will make both sides of the equation as an exponent of the natural constant e. So we will get e to the natural logarithm of x minus 1 over x plus 1 equals y squared, e to the y squared plus c. Here, the law of natural logarithm that will become an exponent of the natural constant e will result only to x minus 1 over x plus 1 equals e minus y squared times e to the c. We get this, it's because of the law of exponents that the sum of exponents will just become like this. Then, any constant raised by the natural constant e will just be the constant. So we will further get x minus 1 over x plus 1 equals c e to the y squared. Now, we already get the general equation for this first order differential problem.
Rectangle.
Here, we will solve another first-order differential equation. By examining this equation, or this given problem, y prime here can also become dy over dx. So, the equation will become dy over dx plus y times the tangent of x equals the secant of x. Here, by examining the equation, we can say that it is a linear differential equation. It's because the general equation for a linear differential equation is dy over dx plus p of x times y equals f of x. Here, we shall determine which is the p of x of the equation and the f of x equation. So, we got dy dx. The p of x of this equation, or the p of x times y of this equation, is the y times the tangent of x, where your p of x is the tangent of x, and your f of x of the linear differential equation is secant of x. The first step of solving linear differential equation is by obtaining its integrating factor, where we will use the v as its representation. So here, the basic formula of finding its integrating factor is the natural constant e raised to the integration of your p of x of the equation. So here, our p of x is the tangent of x, so we will get e raised to the integration of tangent of x dx, and the integration of tangent of x will result to e raised to the natural logarithm of secant of x. Then, using the law of natural logarithm, when it will become the exponent of the natural constant e, what will be left is just secant of x. So we now obtain our integrating factor, which is secant of x. The next step is following the another general equation in order to find the general solution of a linear differential equation, which is y times the integrating factor equals the integration of the integrating factor times your f of x dx, and then substituting the integrating factor, we get y times secant of x equals the integration of secant of x times secant of x. Further simplifying this equation, we will get y secant of x equals the integration of secant squared of x dx. Moving over, y secant of x, y times secant of x equals the integration of secant squared x is simply tangent of x plus c. Then further simplifying to be closer to the general solution of this equation, we will divide both sides by secant of x. So this will now become y equals tangent of x over secant of x plus c. Recall that tangent of x has the identity sine of x over cosine of x, and secant of x also has the identity of 1 over cosine of x. So by substituting its identity in the equation, it will now become as sine of x over cosine of x all over 1 over cosine of x. Let's see. Here we can cancel out cosine of x, since the equation will become y sine of x over cosine of x times cosine of x. Or simply multiplying the equation by cosine of x. So we will now get y sine of x plus c cosine of x. Now we now get the general solution of this linear differential equation.